Hi and welcome to the recap class of time and work. So this is a class where we are going to revise the core concepts and do some high level questions. We are also going to look at some shortcuts and methods that can be used to solve these questions quickly. So my name is Nishant and with me you have already attended the time and work class in detail where we went through all the examples, all the varieties of questions. And in case you have not watched those classes, it will make sense to go back to them, watch those videos, solve the problem, solve some more questions from your exercise material, and then come to this. Okay, this is more of a refresher or a revision before your main exam, or you can do this after you have completed the complete material on time and work. Also for students who have appeared for CAT or other exams earlier and now are looking at a crash course or a fast track thing, then this can work for them. So that is what my advice will be. Okay, that unless you are clear with the basic concepts of time and work, this class might not make sense for you. So be clear there and then you can join here, because here in about 1 hour or so we'll go through all the concepts and we'll do some 10-12 high level questions, some questions which have appeared in CAT and some of very similar level of difficulty. That is what we are going to, and I'm afraid that I may not be able to go in much detail at concept level of each of the question, because I'll assume that you already know that. Okay, so let's get started. So let's get started quickly with a quick recap of the basic concepts. If a person can do a piece of work in n days, then in 1 day he does 1 by n of the work. So if a person can complete a work in 20 days, that means in 1 day he can do 1/20th of the work. Here we assume the work to be 1 unit. Okay, so work is 1 unit. In a day he does 1 by 20. Or there's another concept where we can say that he does 5% work in a day. 5% comes from where? It is nothing but 1 by 20 into 100%. So he does 5% of work in a day. Here we assume the total work to be 100%. So both are fine. It depends on the question. 1 by 20 is a reciprocal and sometimes reciprocals are complicated. So we prefer to use percentage, but both are absolutely fine. This is when one person. If you have more than one person, then what we do is, let's say there are two people. They can complete the work in 8 days and 20 days respectively. Then to quickly get the answer, we basically take LCM of 8 and 20, which is 40. So we assume that the work is equal to 40 parts. Okay, because in time and work, never the work will be defined. We'll have to assume the work to be some unit, some percentage or some parts. We assume the work to be 40 parts. And 40 parts this person completes in 8 days. That means he does 5 parts per day. This person completes in 20 days. That means he does 2 parts per day. Together they do 5 plus 2, 7 parts per day. Now if they do 7 parts per day, to complete 40 parts, they are going to need 40 by 7 days, and that is the amount of time required to finish the work. Okay, so this is one way. Second, of course, is the reciprocal way, that work done in 1 day is 1 by 8 plus 1 by 20, which will take LCM as the 40. Finally, of course, the answer would be same. So in 1 day, work done will be 7 by 40. So days required would be 40 by 7. Okay, so that's how we calculate. You can have more than 2 people as well. And as a formula, the formula for 2 people is AB upon A plus B. So here AB is 8 into 20 upon 8 plus 20. That will also give you the answer directly. So 8 into 20 is 160 upon 28, which will be, we'll cancel by 2, we'll have 80 and 14, and then you will have 7 and 40. So you'll get same 40 by 7. Okay, so this is the simple concept that we use to calculate. Let's look at a question here. A can complete a piece of work in 2 days. So A takes 2 days. B takes double the time. B takes 4 days. C takes double, so 8 days. D takes double, that means 16 days. They are paired in groups of 2 each. One pair takes 2/3 of the time taken by the second pair. Okay, so first pair or second pair takes 2/3 of the first pair. Okay, so who is in the first pair? Now if you see here, we have A, B, C, D, 4 people. 4C2, you can have 6 combinations. What are those 6 combinations? We can have AB, AC, AD, BC, BD, CD. And since you have to pair 2 people, it will be better to use what we discussed just now. Number of days taken is A into B upon A plus B. Okay, so if you look at AB, it is 4 into 2, 8, 8 upon 6, that is 4 by 3. They're going to take 4 by 3 days. A and C is 8 into 2, 16, 16 by 10. 16 by 10 will be 8 by 5. They'll take 8 by 5 days. AD, 16 to 2, 32, 32 by 18. 32 by 18 will reduce to 16 by 9. So 16 by 9. Okay. BC is going to take 8 into 4, 32, 32 by 12, which will be 16 by 6, or it will be 8 by 3. Okay. Then CD, 16 into 8, that is 144 upon 24. Okay. That is 72 by 12, that is 36 by 6, or 18 by 3, or 6 basically. So they're going to take 6 days. And CD is going to take 18 into 6. That is, we had taken before this, we had taken, what did we take? BD was 16 into 4. No, so, sorry. So let's take this again. So, BC is 32 by 12 is fine. BD is wrong. Okay, so let's calculate for BD. For BD it will be 16 into 4, that is 64 by 20. Okay, which will be 32 by 10, which will be 16 by 5. Okay, and CD is the last one, that is 16 into 8, 144 upon 24, which will be, if I cancel by 4, you will have 6, and you will have 36, or you will have 6. Okay, so these are the values. Now one pair has to take 2/3 of the other. So which multiple is 2/3 of the other? Here if you check, 4 by 3, if you multiply by 2 by 3, you will get 8 by 9. I don't have 8 by 9. I have 16 by 9, and I have 8 by 3. So 8 by 3, if I multiply by 2 by 3, I'll get 16 by 9. Right? That means this 8 by 3 is the first pair, and this 16 by 9 is the second pair. A and D will take 2/3 of the time taken by B and C. So which is the first pair? The first pair is B and C, and that will be your answer for this question. Right? Okay, let's move on. Now this is a question that appeared in CAT 23. Interesting question. The amount of job that Amal, Sunil and Kamal can individually do in a day are in harmonic progression. Now what is harmonic progression? If you remember, harmonic progression, if you take in reverse, then it is an arithmetic progression. Okay, and this is the amount of job that they can do in a day. So if Amal, Sunil and Kamal can finish their work in A, B and C days, these many days they take to finish their work, then their 1 day's work will be 1 by A, 1 by B and 1 by C, right? And this is in harmonic progression. Okay, which means that the number of days they will take to finish the work is ABC, which makes it simple. And when they are in these terms, so in fact, so this is in harmonic progression. Now harmonic progression, what happens? When terms are in harmonic progressions, their reverse is in arithmetic progression. Okay, that means if I reverse them, this is what you will get. So this is in AP. That is what it means. That means 2B is equal to A plus C. Arithmetic progression, the middle term will be the mean, right? Okay. And Kamal takes twice as much time as Amal to do the same amount of job. So Kamal takes twice as much as Amal. Amal takes A, that means Kamal takes 2A. So this is 2A. This is 2A. That makes it easier. So it is A plus 2A. That means 3A. 3A is equal to 2B. That means B is equal to 3 by 2A. So now everything is in terms of A. Okay. If now Amal and Sunil work for 4 and 9 days, Amal works for 4 days. In one day, Amal does 1 by A. In 4 days, he will do 4 by A. Sunil works for 9 days. So in one day, Sunil does how much? Reverse of this. So he does 3 by 2. Reverse of that is 2 by 3A. So he does 2 by 3A. But he works for 9 days. So he'll do so much. And Kamal works for 16 days. So 16 by 2A. And they finish the work. Is equal to 1. Okay. So this is 8. This is 3. So you have A in the denominator. You have 4 plus 6 plus 8 is equal to 1. So this is 18. A is equal to 18. A is equal to 18. So number of days Sunil will take to finish the job working alone. B is equal to 3 by 2A. So 3 by 2 of 18. That is equal to 9 into 3, 27 days. So the answer for this question is going to be 27 days. Okay. I'll give you one more question here that you can solve on your own. What if the number of days taken by them to finish the work is in HP? Let's say this is in harmonic progression. They take A, B and C days, and that is in harmonic progression. And then can you solve the question? Please try to solve it and see. And in that case, you'll get the answer as 17 days. I'm giving you the answer, but try and solve. In case I switch the first line and I say the number of days by them to finish the work, that is in harmonic progression. Okay, let's look at one more. This is also a CAT question last year. Rahul, Rakshita and Gurmeet working together would have taken more than 7 days to finish a work. Okay, that means per day the work that they do is less than 1/7, right? Is less than 1/7, otherwise they would have finished the work. So Rahul, so let's say 1 by RH plus 1 by RK plus 1 by G. I'm taking RH, RK because both names start with A. They do less than 1/7 work. Okay, because they're taking more than 7 days to finish the work. On the other hand, Rahul and Gurmeet working together would have taken less than 15 days. Less than 15 days, that means in one day they do more than 1/15 of the work. Okay, Rahul plus Gurmeet, they do more than 1 by 15 of work. They all work together for 6 days, followed by Rakshita. So they all work together for 6 days. So when they work for 6 days, they do less than 6 by 7 of the work. Now work done is less than 6 by 7. That means work left is more than 1 by 7. What is 1 minus 6 by 7? It is 1 by 7. So they have done less than 6 by 7. That means work left is more than 1 by 7. Okay. And Rakshita worked alone for 3 more days to finish the work. Okay. So now work left is more than 1 by 7. She works for 3 days. So if now Rakshita working alone could have finished the work in how many days? Now 7 into 3 is 21. Okay. If Rakshita does 1/7 work in a day, okay, then in not 1/7, 1 by 21 work in a day, then in 3 days she could have finished 1 by 7. This is very clear, but she has to finish more than 1 by 7. That means she can take, in general, if she has to finish the whole work, she has to finish the whole work in less than 21 days. Okay, because in that case, in one day, she'll be doing more than 1 by 21. She'll be doing more than 1 by 21 into 3. She'll be doing more than 1 by 7. So the number of days that she needs or that she will take to complete the work is definitely less than 21. It cannot be 21. And here if you see 21, so the question is cannot be. So it cannot be 21. It has to be less than 21, and you can see that all other values are less than 21. You don't have to do anything else. This data actually is not required. That is enough to give the answer. Okay, let's move on. Then we have work done is equal to time taken into rate of work, right? So in fact, rate of work we use sometimes, or rate of work is 1 upon time taken is 1 upon rate of work. If a piece of work can be done in x days, then work done in 1 day is 1 by x. All this we are aware. X is twice the ratio of men who are required to complete a piece of work. Then the ratio of the time taken by them to complete the work will be y is to x. Then there is one concept here, which is of man days. If x people do W1 work in D1 days, working T1 hours each day, and there's another group, then because the work is same, I equate my man days. So man days are constant as long as the work is constant. Okay, so I equate my man days of case 1 to man days of case 2 and I get my answer. Okay, so man days, man hours, here it is hours. It can be man days also. Either way, we can get this. Okay, let's do a couple of questions to understand this. A work was completed by 3 persons, A, B, C working together. A worked for X hours for X days. Okay, so total X hours, X days, that means he has worked for X square man days, man hours. B has worked for Y days for Y hours, that means Y square man hours. And C worked for 16 hours for 16 days, 16 into 16, that is how much? 256. So total so many man hours of work has happened. Okay, C could have completed the work alone in 29 days for the same hours. Same hours is how many hours? 16 hours. So this is equal to 29 into 16. This is your man hours from the first case, this is your man hours from the second case, and because the work is same, could have completed the work alone. So the work is same. So man hours of first case is equal to man hours of second case, right? So x square plus y square is equal to 16 was common, 16 into 29 minus 16, or 16 into 13 is my x square plus y square. 16 into 13 is how much? 160 plus 48, 208. Now 208 has to be sum of two perfect squares. Okay. Then the work can be completed in approximately how many days, given that x and y are integers. So x and y are integers, so it boils down to, let's list down some initial squares. 1 square is 1, then you have 4, then you have 9, then you have 4 square 16, then 25, then 36, then 49, then 64, 81, 100, then you have 121, 144, 169, and 14 is 196. So up to here we have to see what combinations, right? And because this is a even number, both even or both odd. So 196 plus 4, no. 196 plus 16, no. So 196 cannot. So let's start with the highest value. Then 169. 169 is odd. So 169 plus 1, no. 169 plus 9, no. Basically for 169, you need 31. 31 plus 8, which is 39. So 169 is also not there. 144. If I take 144, then to 144, you need to add 56 plus 8, which is 64, which is possible. That means one combination can be 8 square plus 12 square. Okay, what else? 121. For 121, you will need to add 79 plus 8. That will be 87, not possible. For 100, you need to 108. For 81, you will need to add 81. So we already checked the higher values. So no other value is now possible. So the only possibility is 8 square plus 12 square. Okay, then question is, if all of them work together for their respective working hours, then in how many days? Okay. Okay, so now that we have x and y, A works for 8 hours per day, B works for 12 hours. Ab who is A, who is B does not matter, and C works for 16 hours per day. So together they do 36 hours of work in a day. Into days is equal to total work, which was 29 into 16. Right? Total work was already defined here. So we get 36D is equal to 29 into 16. This can reduce a bit. So 8, 18, this is 4 and this is 9. So D is equal to 29 into 4 upon 9. 29 into 4 will be 116. 116 divided by 9, and the question says approximately, so the answer would be approximate. So it will be how much? 9, so you take 1, then 26, roughly close to 13 days. So answer would be 13 in this case. It will be about 12.9, 12.9 something. Okay, fine. Let's look at one more question. A group of workers was put on a job. From the second day onwards, one worker was removed every day. The job was finished when the last worker was removed. Let's just understand this. So first day X workers worked, assuming they were X workers. Second day X minus 1. Third day X minus 2. And this went on till it became 3, 2, 1 and 0. 0 does not make sense because there's no worker on that day. Okay, so this, if you see, if you just reverse this, this is sum of natural numbers, right? 1 plus 2 plus 3 plus 4 up to X. So the total number of man days that has been put in, sum of natural numbers, if you remember, is X into X plus 1 by 2. So this is the number of man days that has been put in, and this is your work. Now, had no worker been removed at any stage, the work would have got completed in 2/3 of the time. So 2/3 of the time, 2/3 of which time? The total number of workers are X. Okay, and here you can see the number of days taken also are X. Okay, so 2/3 of the time, that means they would have taken 2/3 X. So this is equal to workers into days, which is 2 by 3x. Right? This is what my equation is. So 1x will get cancelled. You'll have x plus 1 into 3 is equal to 4x, or x is equal to 3. So how many workers were there? There were 3 workers. As simple as that. You just have to make the equation correct. Okay, great. Then let's move to efficiency and wages concept. Wages of persons working together is directly proportional to the efficiency. Efficiency also cannot be measured, it can only be compared. Efficiency decides the amount of work done and not the number of days. Very important. Wages are paid for the amount of work done and not for the number of days worked. In fact, that's why wages and efficiency are related. Okay, that's where the first line, wages is directly proportional to efficiency. Okay, total work done is number of days into efficiency. Okay, hence efficiency is directly proportional to total work done by a person, directly proportional to 1 day's work by a person, and inversely proportional to the time taken to complete the work. So for example, if A and B can finish a work in 10 days and 30 days, who is more efficient? Obviously A is more efficient. A is 3 times more efficient because he takes 1/3 the time. And if you have to find their efficiency, you inverse the number of, you find out basically how much time they take, how much work they do in 1 day. So A does 1/10 of the work and B does 1/30 of the work. This is the ratio of their efficiency. Now if you want to avoid the fraction, multiply this ratio by 30. So you will get 3:1. Okay, so if you want to get the efficiency of 2 people, just find their 1 day's work. That is the ratio of their efficiency. Okay, so if A is thrice as efficient as B, then ratio of work done by A and B will be 3:1 if they work for same days. If they work for 1 day, A will do thrice the work as B. Time taken by them to complete the work will be 1:3. So as you can see here, A is thrice as efficient, so A can complete the work in 10 days, B can complete the work in 30 days. Wages paid to them will be in the ratio of 3:1. When they work together, they'll finish the work together. And understand this. So if they work together, then it will be 30 into 10 upon 30 plus 10. That means 300 upon 40. That means 30 by 4. They will take 7.5 days to complete the work. Now, both of them have worked for 7.5 days. But have they done equal work? No. A does, in 1 day, he does 1/10 of the work. So in 7.5 days, he will do 7.5 by 10, or he will do 3/4 of the work. And B does 1/30th work in a day. So in 7.5 days, he will do 7.5 by 30 or 1/4 of the work. So he has done 3/4, he has done 1/4. So you can see work done by them is in the ratio of 3:1. Hence wages should be paid to them in the ratio of 3:1. So that is the core concept here. So for wages, you always look at work done. For work done, you always look at efficiency. So wages, work done, efficiency, they all are related. Okay. Let's say work done by W1 and W2 are done by two people, A and B. A takes 80% more time. So these are worker. So A does 80% more time to do the work W1 alone than he takes to do it together with B. Okay, so these are works. Okay, so let's say A and B can finish the work in X days, then A alone, he takes 80% more time that he can finish in 1.8x or 9 by 5x. That is what it means. So if I see this, 1 by A plus 1 by B is equal to 1 by x. Okay, they do x amount of time, in which 1 by A I know is 5 by 9x plus 1 by B is 1 by x. So from this, 1 by B is 9 by 9x minus 5 by 9x, or 4 by 9x. So B does 9x by 9 by 4x work in a day. So this is how much B does. This is how much A does. So question is, how much percent more time B will take to complete the work W2 alone if he takes alone than he takes to do it together with A. So obviously together with A, they finish the work in X days. Alone he takes 9 by 4x, which is 2.25x. That means he'll take 125% extra time. So answer is 125%. Okay, so simple. That's how you do efficiency question. Let's do one more question here. Okay, so we have three equally efficient laborers started working together to complete the task in a certain number of days. But in the due course of work, they remained absent for a few days due to some reason, and therefore the work was completed 3 days late. Okay. Now, if the work was completed 3 days late and there are 3 people, that means they took 3 into 3, 9 man days extra. Okay, first core concept to understand is 9 man days have been taken extra. So this is the number of man days for which they would have been absent. Okay, all on one day or all on different days, but basically 9 man days of absence should be there. Okay, so first, if the first and the second laborer remained absent for 2 and 4 days more than the third laborer, then the third laborer was absent for how many days? Okay, so let's assume third, first and second. Third was absent for X days. First was absent for X plus 2 days and second was absent for X plus 4 days. These together is 3x plus 6 days, which should add up to 9 man days. Okay, this is the absence, 3x plus 6 man days or 3x plus 6 days these men were absent, which should be equal to 9. That means 3x is equal to 9. That means 3x is equal to 3 or x is equal to 1. So the third laborer were absent for 1 day. 1. This is 1 plus 2, 3 days, and 1 plus 4, 5 days. Together you can see that they were absent for 9 days, and that they had to make up by working 3 days extra. 3 days into 3 people is 9 man days. Right? As simple as that. Okay. Second question. First and second laborer got rupees 10 and rupees 20 less than the third laborer. Then the extra money the third laborer earned is how much? Okay. Now this is interesting. So they got 10 and 20 rupee less than the third laborer. This also means third laborer got more. That means he worked for more number of days than first and second laborer. So first and second laborer were absent for more days than the third one, because the third one has got more salary, and all of them are equally efficient. So how much they get is directly proportional to the number of days that they work, right? Okay. So what do we do here? Let's assume, let's write on another page. We have third laborer, third, first, and second. Okay. What does the question say? The extra money earned by the third laborer is how much? Okay. So third has got, let's say, X. First has got X minus 10 and second has got X minus 20. Okay. Now this money is same. They got the same money when they completed the project, because they got it delayed, does not matter. The money paid to them was same, right? In fact, I think that is mentioned also somewhere here. No, not mentioned, but obviously the money that was given to them same. They had to work for 3 extra days because they were absent. So the total money that they got is this. The average of this is what they should have got had they worked for regular number of days and they would not have been absent, right? So this is 3x minus 30 upon 3, which is x minus 10. So x minus 10 is what each one of them would have got. But instead, third one got x. That means he got 10 rupees more. First one got same. And second one got 10 rupees less. Okay. So you can see the third laborer got 10 rupees more than what he should have got. He should have got x minus 10, but he got x rupees. First laborer got x minus 10, so he got what he should have got. And the second laborer got 10 rupees less. Okay, this clearly shows that second laborer was the one who was absent for more days. First one made up. So he was absent for whatever days he covered by working more on the other 3 days. And the third laborer actually worked more than the number of days he was supposed to work. Okay, right? We don't have to go into number of days, but this clearly shows you that how the money has got distributed. So I think the question has been answered. The question was, then the extra money the third laborer earned is 10 rupees. They all should have got x minus 10, but the third laborer got x rupees. Okay, then the last question. The first and second laborer got rupees x and rupees y less than the third laborer. Then which of the following values of x and y are possible? They got x rupees and y rupees less. Okay. Now here we'll have to understand some concepts. Let me just erase this. Okay. So let's say payment per day. Payment per day is A rupees. Okay, this is what we pay. Now, first laborer, second laborer, and third laborer. It is clear here from the question that first and second laborer have got less than the third one. So again, third one has worked more. Okay, so third laborer could have been absent for 0 days or 1 day or 2 days. He cannot be absent for 3 days, because he was absent for 3 days. Then he worked extra for 3 days. He will match up, so he will get the same payment as others, or at least one more person. Right? So he definitely is absent less than others. So 3 is not possible, because just assume if he's 3, then for others it has to be 6. So it can be 3, 3, or it can be 3, 2, 4, or it can be 3, 1, 5. And in any of these cases, you can see that third laborer will not get more than both of them. Here, all 3 will get equal. Here, he will get equal to this person. Here, he will get actually less than second person, because the second person is absent only for 1 day. So these are not possible. So clearly the third laborer is the one who is absent for least number of days, and it can't be equal to 3. So it can be 0, 1 or 2. Okay. A rupees is the payment per day. Okay. Now, laborer 1 has got X rupees less. X rupees less. So he must have been absent for X rupees upon X total rupees upon A rupees, right? Understand this very carefully. A rupees is what you get per day. So let's say you get 20 rupees per day and you get 40 rupees less. You get 40 rupees less. That means 40 by 20. You are absent for 2 days more than laborer 3. And laborer 3 was absent for 0 days. So obviously it is X by A days. And for you it is Y by A days. Right? And this whole value, so total money that they get less is X plus Y by A. This should be, this is number of days absent, right? This is number of days absent and this is number of days absent. So this should be equal to 9, right? This should be equal to 9 and X plus Y, remember, is an integer. Okay. In case third laborer was absent for 1 day, then first was absent for 1 plus X by A. Second was absent for 1 plus Y by A. And together when you add, you will get 3 plus X plus Y by A is equal to 9, or X plus Y by A is equal to 6. And in third case, it will be 2 plus X by A, 2 plus Y by A. Together it will be 6 plus X plus Y by A is equal to 9, or X plus Y by A is equal to 3. Fine. So these are the equations which we'll get, and then we'll have to work from the options and see which of the options is possible. So if you look at the first answer, it is 18 and 24. So 18 and 24, if I put in the first one, 18 plus 24 is equal to 42. 42 is equal to 9A is not possible. 42 upon A is 9 is not possible. Okay. If I put in the second one, 42 upon A is equal to 6 is possible. That means A is equal to 7. So they get paid 7 rupees per day. In that case, if they get paid 7 rupees per day, then these values also should be positive, X by A. So we had how much? 18 and 24. So X is 18, Y is 24. So 18 upon 7 is not an integer. Hence this is ruled out. Okay. 24 upon 7 is not an integer. While the total we are getting, but the number of days that they are absent also should be an integer. So you can see that 42 is not possible. Here again, 42 upon A should be equal to 3. That means A is equal to 14, which is again possible. But 18 upon 14, not possible. 24 upon 14, not possible. Okay, so the first answer is not possible. The second answer then is 18 and 30. Let's try this. 18 and 30. 18 and 30 is 48. 48 upon A is equal to 9, not possible. 48 upon A is equal to 6, possible. That will give you A is equal to 8. Okay, 8. Then 18 upon 8, not possible. 30 upon 8, not possible. Then 48 upon A is equal to 3, that makes A is equal to 16. So 16 upon 18, not possible. 30 upon 18, not possible. So this is also not possible. We have checked all three cases. Then the third option is 24 and 30. 24 and 30. So then 24 plus 30 is 54. 54, this fits here. 54 upon A is equal to 9. That means A is equal to 6. Okay, A is equal to 6. So we check the first one. here 24 upon 6 is possible. 30 upon 6 is also possible. Okay, so this clearly is a possible case where you can see that third person was absent for 0 days, second person was absent for 5 days, and first person was absent for 4 days. 4 plus 5 plus 0 adds to 9 days. Wages per day were 6 rupees. Wages per day were 6 rupees. Okay, so the first person lost 24 rupees. So wage per day was 6 rupees. So 24 rupees is what he lost. 30 rupees is what the second person lost. So 24 and 30 fits here. Let's check this also, though we have got the answer, but let's check this one also. 54 upon A is equal to 6. That means A is equal to 9. So I get here also, but then you have, so in fact now that it was fitting there, it will fit everywhere, right? So you will have 9 here. So 9, no, A value is different. A value is 9. So you have 24 upon 9 and you have 30 upon 9. So it does not fit here. Then here 54 upon A is equal to 3. So A is 18. So 24 up, no, here also no. So in fact, the only case that it fits is here. So X is 24, Y is 30, wages per day, so you get everything. Wages per day is rupees 6, and first laborer, second laborer, third laborer. Third laborer is absent for 0 days. First is absent for 4 days, second is absent for 5 days. So all these values we know, and you'll have to do this by putting the values. Okay, so the answer for this question is third choice. I hope you have understood this. Okay, let's move on. Then concept of work done. We just saw this, that work done is basically number of men into hours per day into number of days, and this is the equation that we had made. Okay, now here, so your work is equal to number of men into number of days into number of hours, and all that is what we use here. So here we get questions on men, women, children and all that. So if you see here, men and women can perform a job at different efficiencies. 15 men plus 5 women take 30 days to finish a work, and 5 men and 15 women take 60 days to finish the same work. Now here, sometimes in question, the ratio of efficiency of men, women is given. In this question, it's not given. When it's not given, there's only one way to solve this. Let's consider this as one team. This is one team, it takes 30 days to finish the work. If I make the team 30 times, then they will finish the work in 1 day. Right? So let's make this team 30 times. Then the days required would be 1 day. Similarly, this team needs 60 days. If I make the team 60 times, they'll finish the work in 1 day. And then because both the teams are finishing the work in 1 day, both the teams are equal. So 30 into 15, 450 men plus 150 women is equal to 300 men plus 900 women, which will give me 150 men is equal to 750 women, or men is equal to 5 women. This is what we wanted. We wanted this ratio. Okay, so how much is the work? Now work you can calculate from any of them. So here, for example, 15 women will be equal to 3 men, right? 5 women is equal to 1 man, so it means 3. So 15 plus 3, 18 men. 18 men take 30 days. That means the work is equal to 540 man days. Okay, then we have 15 men. So is equal to 15 men into number of days. So D is equal to 540 upon 15. How much will this give you? If I cancel by 5, it will be 108. If I cancel by 3, it will be 36. So the work will get over in 36 days. Okay, let's move on. The digging work of DMRC requires 12 men to complete the work in 8 days. Okay, so work is 12 into 8, 96 man days. Instead, 16 women were hired and they would finish the same work in 12 days. Okay, so this is equal to 16 women into 12 days. So 96 man days is equal to, or let's leave it like this, 12 into 8 man days is equal to 16 into 12 women days. So 12 gets cancelled. 8 men is equal to 16 women. That means 1 man is equal to 2 women. You have the ratio here directly. Okay. And work, we know work is equal to 96 man days. Okay. Now 8 men and 8 women started working together. 8 women is equal to 4 men. So 8 men plus 4 men, 12 men. They work for 6 days. So 12 into 6, 72 man days of work is over out of 96. Okay. The remaining work has to be completed in 1 more day. How much work is left? 96 man days minus 72 man days, 24 man days. Okay, and how many people are working? 12, right? 8 men and 8 women is equal to 4 men, so 12 men are working. And the remaining work has to be completed in 1 more day. So if days are 1, then this 12 men should actually become 24. So 24 into 1 will be 24. That means I'll have to add 12 more men, right? So 12 more men or 24 more women or any combination which gives me 12 man days need to be added so that the work can be finished on time. Okay, so that's how this gets answered. Okay, then the last concept in time and work is that of pipes and cisterns. Pipes and cisterns is where you get introduced to the concept of negative work. So while so far we have only looked at positive work, that people help each other and they reduce the time to finish a work. If there's a hole in the pipe, in a tank, or there's an outlet pipe, or there's a leak in the tank, then actually the time taken to fill the tank will increase. Okay, because all the filling taps will become less efficient because some of their work will get lost. Okay, will get drained out. Hence, we have negative work here. And as you can see, if there is a filling pipe that can fill a tank in X hours, there's an emptying pipe that can empty in Y hours, then if both of them are open together, work done in 1 hour will be 1 by X minus 1 by Y, which is Y minus X upon XY. So the time taken to fill the tank will be XY upon Y minus X. This is assuming that the filling tap is more efficient. It is more powerful. And if the filling tap is more powerful, then X should be less than Y. Okay. For example, it fills in 4 hours, it empties in 5 hours. So you can see X is more efficient. Okay. If the emptying tap is more efficient, then the tank will get emptied. And the value here will be 1 by Y minus 1 by X because this is more powerful. Okay. Or you can still do 1 by X minus 1 by Y. You will get an answer in minus, which is fine. But this is the amount of work that will be done. Okay. So when multiple pipes are opened, the tank will get filled or emptied depends on the efficiency. If the inlets pipe are more efficient, tank will get filled. If the outlets pipe are more efficient, tanks will get emptied. Efficient and powerful are same, remember. So whatever is more powerful, that will prevail, and that is finally what is going to happen. So let's do a couple of questions on this also. So we have 5 pipes, A, B, C, D, E. Okay. They can fill in 60 minutes, 20 minutes, 30 minutes, 8 minutes, and 32 minutes. Out of these pipes, 2 have been converted into emptying pipes, but the efficiency remains the same. When only one of the filling pipes and one of the emptying pipes operate, the tank can be filled in 60 minutes, while other combination empties it in 13 by 72 of the time taken by the previous combination. Which pipes are converted to emptying pipes? So slightly complicated because we don't know which one. So one, I can do this like this, or I can convert them to percentage. Percentage might be slightly easier, but completely up to you. So if you see A, work done by A in 1 minute will be 1 by 60. 1 by 60, 100 by 60 is 5 by 3. So you can also say 1.67 of the tank will be filled in a minute. Okay. How I get this? Basically 1 by 60 multiply by 100%. So you get 100 by 60, which is 5 by 3. Similarly, B, 1 by 20, which is simple, 5% in a minute. This is 1 by 30. 1 by 30 is simple, 3.33% in a minute. Okay, 1 by 8. 1 by 8 is 12.5% in a minute. So this is the most powerful. And 1 by 32. Now how much is 1 by 32? 100 by 32 is 50 by 16 or 25 by 8, which is 3 1 by 8. So 3.125%. Okay. So these are the individual efficiencies. This is the percentage of tank they fill or empty in a minute, depending on whether they are doing positive or negative work. Okay, now this combination, one filling, one emptying, it fills in 60 minutes. 60 minutes, that means in 1 minute 1 by 60 or 1.67%. So now you have to figure out a combination from A, B, C, D, where one should be positive and the other should be negative. And when you add them with the sign, you should get 1.67%. Okay, clearly you can see, and of course, because the tank is getting filled, the one that is filling should be more powerful. So that's why I converted to percentage, because percentage is easier to visualize. So of course, you can see here very, very clearly that B and C. If B is positive and C is negative, 5 minus 3.33 will give you 1.67. Okay, or even there's one more combination which is C minus A. That will also give you 1.67, right? 1.67, 1.67. Yes. So first combination can be B minus C, or it can be C minus A. Both these are possible, right? If you see 5 minus 3.33 is 1.67, 3.33 minus 1.67 is also 1.67. Okay, so both these are possible. So it can be this, or it can be this and this. Okay. While another combination takes 13 by 72th of the time taken by the previous combination. So the previous combination took 60 minutes. Now I am saying this new combination takes 13 by 72 of this combination. Okay, which is how much? Both are multiples of 12. So 5 and 6. So 13 into 5 is 65 by 6, which means 10.83. Right? That is the amount of time it is going to take. 13 upon 72th of the time taken by the previous combination to fill the tank. Okay, so 10.83 minutes. That means how much work gets done in a minute? 6 by 65. In a minute, work gets done is 6 by 65, which is how much in percentage? 600 by 65, which is 9, 585, 15 by 65, which is 9 into 3 by 13, or roughly 9.1 by 12. If you take 1 by 13 is about 6, 7, 8, about 8 into about 0.22%, about 9.22%, which approximately, in fact, there's only one combination that is possible for that, which you can see 13 minus 3 is 9.3, approximately 9.3%. I wanted 9.2, but this gives me 9.3. Is there any other combination? 12 minus 3. If I take this is closer. 12.5 minus 3.33 will give me 9.17, and this gives me 9.375. So 17 obviously is better, right? So that case, this is positive, this is negative. Okay. So, and do we get that from anywhere else? No, of course you'll need 9. So you need higher value than 9, and higher value than 9 is only D. So I have to see D I can combine with what, and D has to be a filling tab. So that's the only combination. So that gives me DC, and C is the emptying pipe. So I'll have to go with this combination where C was the emptying pipe earlier also. Okay, that means BC is the one which, so B is the filling pipe, C is the emptying pipe, and then D is the filling pipe, C is the emptying pipe. So again it gives me C. About A and E, I don't know which of A and E is the filling and the emptying pipe. Hence the answer would be cannot be determined. So 3 we have been able to figure out, but not the other 2. Hence I cannot get the answer in this case. Okay, but a nice question where you can see how this has been solved. Okay, let's do one last question. A tank has 2 inlet pipes A and B along with 1 outlet pipe. A is 100% more efficient than B. So let's say B can fill in 2A minutes. A is 100% more efficient, so A can fill in A minutes, and B is twice as efficient as C. That means C will empty in 4A minutes. When all 3 are open, it gets filled in 16 hours. So 1 by A plus 1 by 2A minus 1 by 4A is 1 by 16. So you have 4A upon 4 plus 2 minus 1 is 1 by 16. So this is 4. 6 minus 1, 5. 5 into 4, 20. So A is equal to 20 minutes. Minutes or hours, whatever you want. So A is 20 minutes. That means this can fill in 20 minutes, this can fill in 40 minutes, and this can empty in 80 minutes. Remember, this is negative. So what percentage of the tank is filled by A in 1 hour? It is hours. So our data is in hours. A in 1 hour. So A can fill in 20 hours. So in 1 hour, it will be 1 by 20, which is 5%. In how many hours C can empty a half full tank? It can empty full tank in 80 hours. So half full tank, it can empty in 40 hours. If A and C are open and B is closed, then an empty tank can be filled in how many? A and C. So 1 by 20 minus 1 by 80, which is 80 upon 4 minus 1, 3 by 80. So time taken is 80 by 3, which is 26, 2 by 3, or 26 hours and 40 minutes. So that is the answer for this question. Okay, so this completes our recap. How quickly you can do, what are some of the tricks and shortcuts that you can use. But basically you can see the time and work does not have too many formulas. What you have to be clear is if 2 people are doing work, then the work done or the time taken to complete the work is AB upon A plus B. If both of them are doing positive work, it is AB upon A minus B. If one of them is doing negative work. Okay, remaining the simple concepts, just apply them. If you need reciprocal, use the reciprocal. If you can convert to percentage, nothing like it, convert to percentage and get your answer accordingly. Okay, time and work gives questions in CAT regularly. We saw some of the questions, but you will get at least 1 to 2 questions every year. So do practice this well and do not miss out on these easy questions. Okay, thank you so much. Take care. Bye-bye.